Welcome, Geobase, to the first iteration of a series of films demonstrating the process of controlling the PACAF-defined geometrical constraints for the SDSFIE 3.0 data model. This first step involved, which will be described here in this video, involves topology. An important note before describing topology process is so that we all need to get smart with spatial resolution and tolerance. Many of our feature datasets live well outside the Esri recommended default values. Not only are they outside the recommended default values, but they differ from base to base and sometimes even from feature dataset to feature dataset within the same basis geo database. So what I've done here is actually create a default database using our catalog, and you can see it's in 54 North, and the domain resolution and tolerance is here. It's listed. XY resolution is 10,000ths of a meter, and the tolerance is 10 times that at 1,000ths of a meter. And you can actually get smarter by clicking on this little blue text here, and it brings up the help, and it has a great document here on explaining what resolution and tolerance actually is. This last quote here, real important to what I'm saying now. The default tolerance is set to 1,000th of a meter, or its equivalent in map units. This 10 times the default resolution value is recommended in most cases. So this is an opportune time to reset all our tolerance and resolutions back to Esri defaults so that we exhibit the same geospatial database behavior across our entire program. This will become more and more important to a geodata developer when automating tasks via geoprocessing, designing newer or different topology rule sets, or even creating network data sets for our utilities in the not so distant future. It's real easy, but I'll just go in and actually show you guys how much our resolutions differ. I'm not picking on anyone, I'm just picking randomly. You can see that how far they off of the Esri defaults. I mean, M resolution is 1, which is 10,000 times that of the default values. Go beyond that and open up some other random samples, and you can see they differ as well. Not only do they differ, let me see if I can bring this up. No, that's not a good example. Let's go beyond FTQW, maybe FXSB. Do some random sampling here. Sometimes the Z resolution is, I've seen it 1 and 2, which is really, really bad. Especially if we want to go beyond our 2D limited scope and go to a 3D model. We don't want those resolutions to be that high. Differs. So yeah, we will not be examining every single domain to make sure that they are safe. What we're going to do is lock us back to Esri defaults. So what we're going to do is open up EggDex, Mr. Laroc's tool here. And we're going to drive to one of the most common utilities. Where are we at? 2.6 to 3.0 GeoQC convert. And you'll notice the output spatial reference box here. I believe in later versions you will be changing that to required instead of optional, just so that we do have to fill this out. But if you drive to whatever projection that you want, let's just say 54 North, and put that in this field here, the database created will retain the Esri defaults, which we want to exhibit the same behavior across the entire base program. These values right here. Okay guys, now on to what I like to term the offensive line of geospatial data, creating a topology. As some of you may know, topology is restricted to comparing feature classes within the same feature data set. There's no way currently to compare a feature class to another feature class that lives within a different feature data set. For instance, if I wanted to compare this airfield surface to within transportation feature dataset to hydrography, natural water body. No, can't do it with topology. This is the sort of thing that will be done later with the data reviewer extension, which is the second stage of PACAF's geometrical constraints effort. So now on to the simple task of creating a topology within a feature dataset. I'm going to use transportation for the example. So what I'm going to do is go to the new, of course, and create a topology, and that will send me to the wizard. Simply click next here. Can remain default transportation topology, no reason to change the name. And this is where the cluster tolerance comes into play. This is why in the intro I discussed the importance of spatial resolution and tolerance. If you have a tolerance of 1 meter, this topology engine is going to rip your data apart. What the cluster tolerance does in topology, when you run and validate topology, it moves all vertices within the feature class that amount of space right here. So let's say you had a 1 meter tolerance. It's going to assume that every vertice within 1 meter is the same. And you can imagine what that does on the curvature of some of your taxiways and aprons and such. Going to hit next, and you're going to do a simple select all. What that does is select all the features within my current feature data set. All of these will be compared. Next. The topology ranking we're not going to worry about at this time, assuming that we're going back to Esri defaults. The Esri default for tolerance is 1/1000th of a meter, so there's really no reason to rank your feature classes. A rank feature class, basically, if you wanted to make an airfield surface area dominant, you'd make it ranking 1. If you wanted a submissive feature to that dominant runway, like a sidewalk, you'd rank it 2. What would that do in the topology when validated would be to move the sidewalk to the runway and not vice versa. It wouldn't move your runway. And like I said, during this effort, our data is going to be so loose and not tight that we don't really need to do this effort. So keep everything at rank 1. If you have the same rank, what it's going to do is if it's within 1/1000th of a meter, it's going to equidistance both vertices. So we're going to add rules, not manually. We're going to load up the rules that we've already predetermined, and you'll get this delivery soon. So what you can see is all these are feature data set reliant, right? So where I'm at transportation now, I'm going to upload this transportation topology rule set into my topology engine. You can see load rules, and you can see some of the sources are not mapped due to the fact that KKA here, Misawa, doesn't have all of the feature data sets or feature classes that is currently in our template. No big deal, just click OK. So you can see all the rules that are now uploaded into our topology. Hit next. And again, you can see it. I'm going to click Finish here. Just going to create the new topology. The new topology has been created. Would you like to validate it now? I do not prefer to validate it now, due to the fact that sometimes if you have so many feature in your feature classes within your feature data set, sometimes when you're validating the topology within our catalog, it doesn't give you a topology engine error or anything. It'll just run until it can't run anymore. You only have to worry about this kind of thing when you have thousands and thousands of features. Hopefully, with us using EggDex and cutting out the site polys, we won't have this problem. Personal preference. I prefer not to. I prefer to validate an ArcMap, which I'll go over later. So now you have a topology within your feature data set. You can preview it. You can see where all the settings are, rules, and if you validate, you can see all the errors that have been broken here. which you can, export the file, and if you're in a production shop, that's pretty important. Alright, validating topology in ArcMap. I'm going to load the topology rule set that I just created. Tips and tricks here. All you need to do is select the topology, and ArcMap will actually want to add all the features that participate in the transportation topology. You don't have to select all of them. So it loads all my data up. I'm going to start editing. And I'm going to put this to the topology toolbar over here. It has different options like validate topology in a specific area, validate topology in the current extent. I prefer customizing. There's a button on here. And forgive me, I have 1,000 extensions here, so it'll take a while. Alright, I'll go down to topology. And I'm going to scroll down to validate entire topology. That way, I will never miss any site polys that are out there. So I'm going to simply click this one. Yes. You notice it's finished. I actually paused the recording there. It took roughly 30 seconds. Not that bad. We don't have a lot of data here. So you can see it automatically symbolizes here. And in the next section, I'll tell you how you can customize that as well. Alright, symbolizing the topology is like any other data set. Right-click Properties and click on the Symbology tab up at the top, and you can see where you can either have a single symbol or symbolized by error type. This can be a good visual way of knowing what exact errors are occurring in your map. Maybe a little bit over the top, but maybe you prefer to do it this way. Hit OK, and you can see everything is color coded, so I know instantly what kind of errors are occurring in my data set. I'm going to zoom in on the airfield a little bit, and you can see that there are tons of little overlaps that are occurring, mainly I think it's between sidewalks and parking areas. We'll go over the air inspector next, alright? The Error Inspector tool allows you a systematic way to find all of your errors. Instead of looking at this mess of colors here that we have symbolized, you can systematically approach and determine which topology rule that you want to correct. Doing this one by one can clear a lot of confusion that can occur, especially when you're looking at pavement branch versus airfield surface. Two feature classes that can technically exist on top of one another. For example purposes, I'm going to go to road centerline. I'm going to click off visible extent only so I can see the entire database. I'm going to search, and I can see all my calls here. You can further determine what the rule is by show rule description, and you get a better diagram of what's going on. If you do these one by one, it'll be a lot easier. If you do them all at once, it'll be a little confusing. Right-click automations in the Error Inspector tool allow you to do a lot of work efficiently. You can do a shift-click select and select multiple calls at one time. And by doing a right-click split, it performs a function on all of the things selected. There is a little caveat to this situation, if you do an aggressive select on every single call here, if there is one little overlap going on instead of intersect, it won't allow you to do either automation. By showing the rule description, you can see the difference. This is an overlap and this is an intersection. By lessening the aggressiveness of your call, you can systematically go through all your calls and split automation here. Once you find the subtract, you will be able to subtract that one call. Usually it's one or two in your entire data set. Moving on to polygon calls. Automation, I would basically frown upon. The automation is a general subtract, and what it does, it subtracts from either polygon, both polygons. So if you run a subtract on, for instance, this guy right here, and again, I'm going to use this fixed topology error tool to individually click it. It's going to bring it up here. If I do a subtract, I'll show you what happens. It's going to create a gap between the two. Instead of deleting from one to the other, it has no way of knowing where to delete, so it deletes from both. And that will cause a gap in your data. And you don't want a gap in your data. Trying to show a different scenario. Here it is. Same scenario, same overlap between each other. Tons of little guys going on in here. The preferred method I would rather use is a little tool in the topology toolbar, which you can customize through your customize mode. It's probably not a default tool. It's called the line edge tool. If you click this, and I usually turn off the topology symbology, you can go in, find these little overlaps and gaps, for instance. Gaps are one thing that will not be found in the topology engine. We'll do that later when we run our RBJs through Data Reviewer. The topology basically is too aggressive with gaps, and it's going to throw a lot of exceptions for you. So we've isolated it down to the RBJs and Data Reviewer. To do this line edge tool, you just simply click one face and move it to the next, however you want to move it. And you can see how it makes a nice little coincident edge there. And you can progress down at a pretty rapid rate. All right. Of course, there's 1,000 different tools that I haven't described here in this scenario. As always, a great place to look for more enticing tools and how topology actually works is the ArcGIS 10.1 help. It goes into extreme detail, much like the spatial intolerance section as well. Tips and tricks and how Z topology behaves. Topology rules section, which actually goes into each call that I've actually included in your rule data sets. So feel free to peruse, and that'll conclude our topology discussion. All right, good luck, guys.